We are talking about properties of rational exponents and radicals. And we're going to talk about simplifying the following expressions. So for the first one, we see that we have two terms inside the parentheses. We're joined by multiplication here. The issue is that we have different exponents, so we can't do that multiplication. So what we can do is we can take this exponent that's outside the parentheses and we can distribute the exponent to both terms. And what we end up doing is, because this is the exponent out top, that's going to go in the numerator of our exponent. So 5 to the 3 over 3 times 7 to the 3 over 4. And from there, we cannot reduce 7 to the 3 over 4, but 3 divided by 3 is 1. So that just becomes 5 times 7 to the 3/4. Next example, we have the same base where we have two different exponents joined together by multiplication. So a way that we can rewrite this is we can write just one base, and then we can take our exponents and we can add those together. So 3 over 4 plus 1/2, and 3 over 4 plus 1/2. Another way that we can rewrite this 1/2 here is this can be 2 over 4, so that we can add the two fractions together. We have to have a common denominator. So 2 to 3/4 plus 2/4, and then this is going to be equal to 2 to the 5/4. Another example that we have is we have the same base. So we have a base of 3 and we have a base of 3 here. This time it's raised to the 1/4. This one up here is understood that that's a 1. So when we have the quotients here, we can write this as the same base, and then we can have use subtraction to combine the exponents. So 3 and then raised to the 1 minus 1/4. And in order to subtract this, we need to make sure that we have a common denominator. So 1, another way that we can write 1 is we can write it as 4 over 4, just to get the common denominator. So 4 minus 1, and our solution for this one is 3 to the 3/4. Next one over here. This one's a little bit different, where here we have the same base with different exponents. Here we have different exponents, but we have different bases, but we have the same exponent. So what we can do is we can kind of factor out the exponent, and we can rewrite this as 20 over 5, and then we can take the exponent out. So if we were originally like this, we could distribute this, and that would be back here. And then that's still raised to the 3rd power. So we can start doing the math here. And what we see is 20 divided by 5, we know that is 4. So we still have that raised to the 1/2 power. And then we still have that whole thing raised to the 3rd. We know that the square root of 4 is going to be is 2, and that's raised to the 3rd power, and 2 to the 3rd power, that is equal to 8. We have to consider the possibility that the number under the radical was also a -2. So we have to do the +2 there. We also have to do the -2 to the 3rd power, which would also be -8. Because again, if the radical has an even integer, we have to account for both the plus and the minus unless we're told otherwise. And then we have one more example. Again, we have two different bases, but we have the same exponent. So what we can do is we can factor out that exponent. 6 times 2 raised to the 1/3 power. And then in this case, we can say 6 times 2 is 12 to the 1/3. And we cannot simplify this any further than that. So that is our solution.